everybody can see hopefully well enough.
Make sure I brought notepads. I didn't bring a pen. It's a good move on my part. Not prepared for class.
I was going to say, I think most of this, it's going to be the word problems that are, I kind of want you to pay attention to, because that's like the practical part of this. So, anyway, everybody, welcome to High Angle Target Engagement. HATE for short, or acronym if you want to make it. I just did that because it was funny. But mostly we're going to be talking about theory, marksmanship fundamentals. So, course schedule, obviously today is Saturday. We're starting about 2.5, 3 hours later than I expected, but we'll also get to shoot 2 to 3 hours later than I expected. So we got plenty of stuff. I allotted 2 hours. I don't think it's going to take that, but just in case. Next thing we're going to do is we're going to go out. We're going to do our flat range zero. So just establishing 0 to 100 yards. Just go out, shoot, make sure everybody's gun's doing what they think it's doing. Go ahead and have lunch after that. I thought this would be more scheduled than it is, but we'll do what we can. After that, we'll then go ahead and take... Is everybody using a ballistic cap of some kind? Okay, just pen and paper it, or put some English on it.
I've got an app in my phone.
Yeah, I was going to say you can borrow somebody else's app, I'm sure, if you want to. And then we'll go ahead, we'll try to do elevated target engagement, and then we'll probably do dinner. I'm not sure what the order of that's going to work out to, but since we're starting late, but you know, Sunday, that's supposed to be our short day, I think, right? I don't know. I'm counting on you guys to tell me some of these things because I don't know everything. I figure we'll do an after action review, see how everybody did yesterday. And then we'll start doing depressed target engagement tomorrow, which will be shooting down from a hill. So today we're going to do flat range, and then we're going to shoot up. So clean up, lunch, after action report. So this is the overview of what we're going to talk about. We'll talk a little bit about the equipment. Most of that's going to be covered when we actually get out and start doing some practical shooting. We'll talk about the mathematics and theory, determining angle using various tools. Oops. And other marksmanship related tools. I have a couple of examples here that we will get into when it is time appropriate to do so. Generally, if you guys have any questions, please ask. So I want to make sure I'm communicating it to your satisfaction. Well, how familiar are you guys with range estimation? How comfortable are you with it?
As far as what?
Is being able to use your scope reticle for doing your range estimation.
I don't.
Does everybody know the formulas? Do you want to know the formulas?
Sure.
Okay, so the basic, let me just double check my notes here. So the formula for, if you're doing metrics, so who's shooting mils here?
Got mills.
Couple of people. So that would be the range to target is the target size in centimeters, side to side, or top to bottom, whatever it is. And then divided by the target size in mils. So this is what it is apparent in your scope, multiplied by 10. And that'll give you the distance to target in meters. So if you guys have any questions about that, you can hit me up. I'll show you my notes afterwards. At the same time, for those of us shooting mils, the target size in inches, so side to side, top to bottom, either or, divided by the target size in minutes of angle, multiplied by 95.5. And that'll give you the output in yards. And then shooting range, we'll talk about positional shooting, flat range zeros, depressed zeros, all that stuff when we get to it. A little bit about me. So my name is Andrew Van Laar. I usually just go by Drew. Some of you guys might know me from Twitter, and I also go by Ammo MFG. So that's kind of I don't know, that's how I got started on this group. I was a long-time competitive rifle shooter, small bore in Southern California. I took a couple of state titles, way back in the day, back when I was still a junior shooter. Then I shot high power for a while, had a lot of fun with that. Last couple of years, I've mostly done target shooting, long-range shooting, just kind of various various unsundry means. I've done a little bit of F-class. I don't like F-class that much. I usually like doing PRS kind of stuff, so which is more like what we're doing here in the field. I've also played opposing force or bad guy for LA area SWAT teams, and I have a lot of contact with law enforcement, just kind of due to my normal job. So my normal job, I'm an automation engineer. I also am an ammunition designer and an ammunition manufacturer. So equipment, did Braxton send you guys this ahead of time? Even though I asked him to? Okay.
Yeah. He said bring sleeping gear and shit like that.
Okay.
He
Well-
sent me that.
Well, somebody got it.
I did
That's
see
more
it.
info than I got.
I guess we know who the teacher's pet is. One guy
I
got
guess
it.
so. I thought he sent that to everybody.
I was going to say this is pretty basic stuff. You're no.
I asked him what to bring. He said, Randy said, bring your wife.
Hmm.
I said, I got nothing.
Well.
What else?
PPE, eyes and ears, basic stuff. Hopefully you all brought a rifle with a scope. Anybody not? Okay, I don't think so.
I apparently did not.
Well, you did bring a rifle with a scope, it just
Remains to
doesn't
be
work.
seen.
But you did bring a spare rifle, which is actually pretty
Yes.
good. Dope book. Everybody got one of those? Brought one? Whatever. We'll wing
That
it.
notepad.
If you got honestly, if you got a notepad, that's the start
That's
of
where
a
I
dope
keep my
book.
notes for my
So,
gun.
one of the things we do have, we have a magneto speed. So if you guys want to get your velocity, if you don't know what it is, we can take that while we're out at the range. If you've got a calculator, that's kind of preferred. Your smartphone is A-OK as a calculator. Shooting sticks, other stuff you need for doing positional shooting, bipods, tripods. Usually for this, because we're going to be shooting at angle, you're not going to be laying down. So, because if you're on some of these angles and you're laying down, your blood rushes to your head. So you're going to be shooting more like a supine position rather than a prone position or a sitting position, something like that. Spotting scope binos, bag to cover everything in, some cordage might be handy. Optional angle finders, laser range finders with inclinometers, most of them have that built in. Kestrel weather station device, radios for range control. I think I'm the only one who brought radios. Anybody else bring a radio?
I don't
Sitting
think
on top of the safe. Box.
Back at home, huh? Okay, so now we're getting to kind of the meat and potatoes
That
of
would
it.
have been a good list to have.
So the question is, what is high angle?
Home and get back
What does
before
high angle mean to you guys? Something other than flat?
Yeah, I mean, obviously I'm in Idaho, so everything's kind of
Yeah.
high angle,
Yeah. So I'm just, for the sake of argument here, I'm defining it as anything greater than 20 degrees. The reason for that is if you really start playing with angles, unless you're using a lot of scientific instruments, it becomes kind of hard to determine exactly what angle it is. I mean, in most cases, you're maybe able to differentiate like 5 degrees or so. Some of these things, like if I get into one of my tools here, my inclinometer, that'll give me a reading out to several decimal points, but maybe this is practical, maybe it's not. Does anybody know what the difference is between high angle and flat shooting?
what the difference is.
What's
Yeah,
flat?
like what changes when you go from shooting in a flat range to shooting
The
at
effective range.
your effective range? What else does it do? Like where's your point of
The
impact
shorter your
change?
effective range, the more your impact. Raises your impact.
Yeah,
So
generally.
your dial up goes down.
Pretty much, yeah. Because usually when you're shooting across, like everybody taking geometry here.
A long time
So
ago.
you remember the hypotenuse and the legs
Sort
of
of.
a right angle triangle. So you're always shooting across the hypotenuse. At the same time, the bullet travel is always a parabola or some segment thereof. So that becomes a little bit more complicated, but anyway, we'll go over the Pythagorean theorem. Sine and cosine are probably the two most, cosine very specifically is the most important function we're going to talk about. When we get to, you'll see in a second. Also talk very briefly about the unit circle. That's kind of, if you're trying to go from a sine or cosine, if you don't have a scientific calculator, you can use the Pythagorean theorem. The mathematics is, I won't say simple, but it's easy enough to do by hand. And then we'll talk about angles and how they affect target size or your hitbox. So, and as well as the difference between uphill and downhill. So, rifleman's rule, this is kind of the core of everything we're doing here. And this was kind of what you hit on. And the drop is computed for the cosine of the distance. So that is the x component of the trajectory or of the ballistic solution. But your windage always follows the full length of that range. So when you're sitting there trying to take and punch all this stuff in your calculator or using your lookup table, you have to use two different numbers. Now, one thing about this is it's not 100% perfect. It's close. It's close enough for government work, but it's not always exact. And maybe if you've got like some really exotic situation, like one dude I was talking to when I was kind of doing my prep work for this was a guy who shoots at like pigeons in grain silos. So like I've never been that close to a grain silo, but you look at them, they're pretty damn tall, right? So this dude is standing on the ground like 20 yards from a grain silo and shooting up to 180 yards. Like those things are that tall. So, and he's talking like, 70, 80 degrees of like up angle. And so he has to sit there and compute it, and yeah, the rifleman's rule is not perfect for that situation. So if you find it, there's other solutions out there. Brian Litz talks about it, Ryan Kleckner talks about it in their books. I'm not really going to cover it because it's very technical. My inclination is to just say use a calculator. Okay. Everybody took 7th grade algebra, right? Or geometry. So Pythagorean theorem.
So I went to school in Idaho. We learned that in the 11th grade.
11th grade? I'm surprised you guys didn't need it sooner.
No, we got that earlier.
Yeah. I don't even remember when I was actually introduced to this. But Pythagorean theorem, very basically, is you've got the two sides of the right triangle, and then you've got the hypotenuse. So if you want to use this as an example, you're up here shooting down to here. This is the path of the bullet. This is the distance that you're computing. And that's given by, as you can see here, this is the cosine. So imagine you're here shooting up. The distance here is the cosine. So you say that this is 500 yards. You're shooting at this angle. Your effective distance is, the cosine of that. So shooting uphill, this is a little bit what I talked about. This is kind of the mathematics. This is going to start to get into calculus and far too deep in the weeds for this class. But this is kind of the basics of what it is. So when you're shooting a flat range, you're always shooting a parabola. That's the path the bullet follows. And when you're shooting up or down, the bullet is still following a parabola. So when you talk about the difference between your point of line of sight and point of aim, you'll see that because it's always a parabola, even though the effective distance might be the same, you'll end up, sometimes when you're shooting up at those really high angles, you'll actually start shooting higher than you would expect. Even more than you would expect using the rifleman's rule. So, mathematics and theory, perspective. And this is what I talk about with hitboxes, because now you're shooting, either down on a target or up on a target. You're shooting at, your target is effectively smaller. So this also comes into play with like very extreme range stuff, where when they've got, the bullet, because bullets slow down over time, and what they actually lose is they lose direction or lose velocity in that X component direction. So when the bullet's coming down, it might be coming down near vertical. So that means your target size is actually smaller. So sometimes if you look at like what these ELR people, like those people who just set the world record or whatever, what do they have, like 30 degrees of angle on that?
Something like that.
And their target was like a bed sheet or something larger than that was actually sitting at this angle.
Huh.
Because otherwise, like the bullet, it would be coming in it's such an angle that they just couldn't get into it. So we'll talk about how to compute this. Okay, tools. So this is a digital inclinometer. You construction people are probably familiar with these. Can be handy for setting up your saw blades.
I still have one of the old school ones on the left.
Yeah, the scope, or
Yeah,
one of those
yeah,
ones.
that old dial.
Yep. So I just got this one because it was nice and easy to carry, and it was $10. So, and the nice thing is,
Pretty inexpensive and small.
these things have magnetic bases. So if you need to just take a measurement real quick because you're not sure, you can just go ahead and slap that on the barrel, take a look, throw it in here, compute your solution. Slope doper is another one that's been around for a while. It's just kind of an aluminum, thing. The nice thing about this one is that it already has your cosines. So that's these decimal numbers here. So that's the number you have to modify. I don't know, especially for stuff that's oriented towards shooting. I don't understand why they even bother putting stuff out in the angular, in the degrees, when they could just take and just give you a cosine. One of the other ones, so this little doodad here actually clips onto your gun. This one's made by Badger Ordnance, so that one I didn't bother buying one because it's like $250.
They're expensive. I had one on order, but it wasn't going to come on time.
Yeah. So I was like, wowza. So I did manage to get this one. It's Chinesium, but it was $20 on Amazon.
Does it have the cosine on it?
No, it doesn't. Neither does that one. It's almost the same thing. It has 5-degree increments. So
Badger makes one now that has the cosine
do they?
on it. Yeah, it starts from goes like 0.97, 0.95, and or
Okay.
whatever it is.
I mean that's the way to do it because it's like there's that.
And then you
But
can just multiply your.
multiply your range. So it makes it easier. This is kind of the old one. That's the Mil-Dot Master. This one actually gives you full degree marks, but at the same time, when you're like sitting there holding it on top of the rifle, holding the rifle on target, this is almost one of those things where you need a spotter to help you out. So, okay, who's ready for group exercises? So, remember word problems?
Sounds good to me.
So you have laser range found at distance that is 380 yards with a 22-degree downslope. So you're shooting down. What is the effective target distance? How would you set that problem up? Okay. So remember rifleman's rule? Drop is computers.
280. The cosine or the range on that first word problem was 280.
380.
380.
There you go. So what'd you get? So to set this problem up, you should pull out your calculator, type in 22, cosine,
Cosine 22.
and then multiply that by 380.
352.26.
Yep. And that can be meters or yards. It doesn't super matter because we're just multiplying by an otherwise unitless measure.
So it's just you just cosine of the angle.
Yep.
5 times the range. Okay.
That's the really basic one. So when we talk about the differential in target shooting box size, if you've got a 12-inch round target, so I was hoping to have a round target, like a panlet over there or something.
What'd you come up with? What was the answer on that?
352.
What was the formula? The cosine angle times what?
Yeah, cosine angle times range. So do we have? Hold on.
Cosine angle gets by the flat distance range.
not clear, we can, I'll give you the formulas afterwards. So when we talk about number 2, I was hoping to have a target that I could present and be like, okay. So when we talk about hitboxes, if we know that a target's going to be 12 inches round, and steel targets are usually sitting mostly flat in presentation because they're hanging from chains or something like that. If the distance is 120 yards and you're shooting down, down at 55 degrees, so that means you're up here and this is up here, right? Or you're up here, this is here. So how big is this target presenting? Now if I take and rotate it down to where you guys are sitting, it's sitting like this, right? So how big is this target?
Not very.
So in this case, we can still use the cosine rule. So we take cosine of the angle, and then rather than going by range, we go by the size of the target. I want to dump that into their calculator.
It was like 6.8, 6.9.
Yeah, close enough. 6.88.
What was the size of the target?
12 inches. And then part 2 of that question, it builds on part 1. What is the effective distance to target? So take cosine of 55 multiplied by 120. And what's your distance?
68.8.
Bingo. Okay, now I'm going to start getting a little bit harder. So you have a target that's rectangular, obviously. It's 22 inches wide. It's 30 inches tall. It's hung vertically, just like our board was. It is some distance below you with a depression angle of 30 degrees, so you're shooting down on it. So this is kind of like B. It appears 4.5 MOA wide. Because one nice thing about when we're talking about these perspectives is that the width of the target, as long as it's straight at you, is not going to change. So, using the formula from part A there. Oh wait. So we got to use the range formula first. So I did it in either mil or in MOA.
Is the 99.5 or 95.5 in the denominator on the MOA?
It's
Or is it
no,
after?
it's after. So take the target size divided by the size
Right.
or
Then-
the apparent size, then take that number, multiply that by either 95.5 or by 10.
Okay.
That's what you guys get for the part 1.
Uh-oh. 423?
Is that in yards or is that meters?
I guess it'd be meters.
Okay.
I got 440 yards.
Let me double check my math here.
Although I make things complex because I use yards and mils.
Yeah. Yeah, that's like 27.5, I think.
Yeah, I don't remember
I
the
don't remember
numbers
what
off the top of my head. I knew it at one time. But
I always tell you if you're using pick one or the other. Either use metric or use SAE.
yeah, it's more work to convert them.
Yeah. I'm just gonna double check because I got a different answer than you guys. Because I got 466 yards. So that's for part A. So what you want to do is you want
Yards, yeah. 22 divided by 4.5
yes,
times 95.5.
yes,
Then cosine of 30.
no. Because we're
Times
only
10.
computing the distance right now.
Uh,
You got ahead of yourself.
Okay.
So the next part is that you say that it appears 4.5 wide. What is the effective target?
Okay, that's the question I was answering. Is what is the effective target distance?
Correct. Okay. Yes.
Yeah.
Okay. The next question is what is. So you know what? I didn't put the right answer here. So yes, you guys were right.
What was the formula for the first part?
It is the range formula. So it is the size of the target divided by the apparent size of the target multiplied by the modifier, whichever, whether you're using imperial or metric units, and then you need to take the cosine of 30 and then multiply that by that number. So what'd you get? You said 404?
404.329.
So there you go. There's the answer. So, and then next part goes, what is the height of the hitbox in inches? So that was, you already answered that problem in part A of part B, question B. So that's the target, and you're shooting at it this way. So you know that it's 30 degrees tall, or I'm sorry, 30 inches tall. So that would be cosine 30 times 25. Yep.
65.8 centimeters.
I didn't write down the centimeters, but I will accept it. Okay, and then the last question, this uses all of the formulas we already used for those ones. So 22 wide, 30 tall, hung vertically at some distance below you. In your reticle, it is 6.5 MOA wide and 6.2 MOA tall. What is the range to target, and what is the angle of depression? So, do you guys want to crunch on it for a second, or you want me to tell you?
Yeah, I don't remember. I mean, I wouldn't know how to do that.
Start to
That
walk
figure,
through
So
it.
you need to calculate the size based on what it appears in the reticle, and then
You already know what its apparent size is. It's 6.5 mils. So you need to say 6.5 mils, and go by 22 the width.
right.
That'll give you the range. Like the hypotenuse range, we'll call it.
Okay, so it's 323 yards range to target.
Correct. Okay, now you know how tall it is in its apparent size,
Right.
but you know that it's actually 30 inches tall.
Yes.
Okay, so remember the formula that we use for calculating the apparent size, the size of the hitbox? So now we work that one backwards.
Yes. Okay.
So you have to compute the range, so that would be, yeah, so essentially what this turns into is you have to take this size, the 6.2 MOA,
And I have to plug that into the range formula and then solve for the unknown and then do the same thing with the cosine
correct.
formula.
So okay, so remember how we found the range using the width of the target?
Mm-hmm.
Now what we can do is we need to find the range again using the apparent size of the target.
is.
And since we know the apparent size of the target, or actually no, let me rephrase. Since we know the apparent size, we have to work backwards. So what it ends up being, since we know the target distance, which is 323, we have to kind of work this a little bit backwards.
Mm-hmm.
So we then take that, divide that by 95.5, and then multiply that by 6.2.
Oh, yeah, right, yeah. So I go through. Yeah, I'm not tracking.
So okay, so
Yeah,
you're
289 meters. The target. Based on that.
323.
I mean meters?
Oh, I'm sorry. Yeah, okay.
Okay,
It's okay.
so I got my meters.
Think of it this way. Okay, remember how we computed the effective hitbox size? So we're looking at it like this. Okay,
Yeah.
so it's 6.2 mils tall,
Mm-hmm.
but we know it's actually 30 inches tall,
Oh, okay, yeah.
and it's 22 wide. So that allows us to compute the distance to the target. And now using the hitbox size, we can move backwards and we can calculate our angle of depression.
Yeah, I'm not too good at math on this stuff.
Yeah.
I'm not understanding the back calculation on it.
So what we're doing, so remember how we calculated, so okay, let's go back to B real quick.
Yeah.
So you've got a 12-inch target, okay, it's round, and it's leaning towards you. And with that lean, it has this effective size.
Yeah.
This effective size is how many inches, right? You already gave me the answer for this. Now, since you know how big it is in inches, how big is it in your scope? How big does it look?
I didn't
Make sure
put
I'm
this on.
understanding all this shit.
I didn't get this on my page. I'll help you.
So essentially, this case is the one you're going to use. If you don't have anything to measure an angle with, you can, if you know the size of the target, you can still derive the angle and be pretty exact about it.
Yeah, 45.6 degrees.
45 is what I was looking for. So you want to tell the rest of the class, or?
Sure, yeah. So it's easier if you write out the formulas and but don't do it in your head, because it's just like high school, middle school algebra. You're solving for the unknown variable. So each of these formulas, you can take any of the known variables and combine them to find the unknown variable. So if you use the range formula, target size divided by target in your reticle, in your range, we found the range, or when we first started the problem, and we got the 323.23 as the range. So you have everything except for your target size, your apparent target size.
In the vertical direction.
In the vertical direction. So you have to solve for that, so that you're solving for t in the numerator of that equation. And then I'm doing it in MOA, so I got 20.956 as what I'm seeing, the effective hitbox vertical size. And then you put that into your angle formula. So you've got cosine of the angle multiplied by the size of the target equals the angle adjusted size of the target. So you have everything except for your angle in that one. So then you divide the angle adjusted size by the actual size of the target, and then you take the inverse cosine to, again, you're just solving the equation, take the inverse cosine on both sides. So you're then taking the inverse cosine of 0.698 in my case, and you end up with 45 degrees.
That's it.
It's an out. It just becomes an out.
Inverse.
That's all these
Just
are.
like taking, just in your if you have a scientific calculator,
Yeah.
It'll be cosine to the -1 power, or it'll say arc cosine.
Yeah.
That's your inverse cosine. It's just like taking the square root of something that's.
Oh yeah.
So it's the trig version of taking the square root.
Can't
Yeah,
write
I don't
down
have that on this.
Yeah.
So the range.
I have to sit down and work with this a little bit
Okay.
and practice it some to get it to really get a handle
So
on
I
it.
I was gonna say
I'm not good at math at all.
I'll
Not
give
algebra.
we'll give
6.2.
Braxton a link to the slides so that you guys
Target in
can.
inches.
Perfect.
The answers are actually in the notes.
Yeah, I've never tried doing this
I use
before.
Well, yeah, that's why you're
You're
here.
gonna work target in
Yeah, no, that's what I'm saying. I need to sit and work with this. I have to look at that,
Yeah.
do it in my head till it really
times 10
clicks.
I mean, for the most part, we're not really going to be touching that today.
Yeah.
equals range.
It's just
Well, wait.
Yeah, most of my stuff's like obviously
Yeah, okay.
killing animals, but
yeah.
there's no time to like. We're just it's all by like trial and error over the
Yeah.
years, you know.
Cosine of the angle.
Yeah, that's where.
Which one
I mean,
is
what it is that you can take and
this is
put
for
stuff like this on your optic.
Yeah,
You know, so now you can be like, okay, well, let's you know, let me hold it still for a second. Okay, it's 35 degrees down. You know, if you've got like an arm board or arm chart or something like that, I mean,
Right.
okay, I think it's this far away.
a lot of guys will do that on the butt stock load out.
I've never tried to figure effective target size based on the angle before.
Yeah.
It's more like
A lot of
figure
people
out
though,
the
that's
figure out the range, just hold center.
a lot of the stuff
those are the two.
is really like law enforcement oriented. Because usually you're talking about like no-fail shots on like, you know, hostage takers and crap.
Right, they have a little bit of time. They can figure
Yeah.
everything out and then apply it.
Yep.
Yep.
So
So then what would be the relevant application of the effective target size in
Well,
a
okay.
situation like that? I
In-
mean, if
in
you
this
know
situation?
the angle and the like if you know the distance you're shooting for,
yeah.
what is the relevance of the effective target size if you're trying to? I mean, if you're just trying to hit the spot.
Let's say, you know, it's like, okay, I know that I'm a 2 MOA shooter. I mean, maybe you don't have to go all the trouble of being like, oh, well, let me calculate this out, how many MOA that is. You can be like, yeah, you know what, maybe I can't take this shot from here. You know, or maybe the target needs to do this or that or the other thing in order for me to get the shot I want.
Okay.
Change
If-
your margin of error.
Yeah. Change your margin of error. But where this also starts to come into play is loophole shooting. So if you're like, okay, my loophole is, 10 yards away, so I'm shooting through a hole at a target on the other side. And it's like this was stuff we used, that was used in Iraq more so than in Afghanistan because you're talking about these really complicated urban fights. So it's like, yeah, as if a team is out there and gets compromised, they could have, the Mahdi army on them, launching RPGs at the building until it's rubble. Where it's like, okay, we've been here for a couple days, we're looking through this loophole, we're looking for 1 HVT. Can we shoot through this loophole and can we hit the target at the distance we think we're going to be able to take them at? So, like I said, law enforcement, military application, but it's just one of those things. It's put it in your think box. Okay, well, I mean that's pretty much it for the lecture. Is there any substantial questions that I haven't answered, or if I just
A little of that, but
okay?
it's good.
I want time to I want to be like, okay, here's everything. Like, I don't expect it to soak in immediately.
Right.
So let's go do some shooting, have some fun. Kind of let these things, kind of percolate, and hopefully it'll come out to your benefit. I don't know if we'll calculate range table. Those of us who have ballistic apps, that's probably the way I'd go.
I've never used one.
Yeah. So one thing I actually
You said you had one, huh?
yeah, a really easy one is like the Hornady app. That's free. So let me see if mine powers up here. One thing is, as far as when we were talking about angle finding tools, the Hornady app does have a built-in inclinometer that uses the cell phone.
Oh, really?
So let me see if I can pull it up here. I think it's the 4DOF calculator. Favorites. So let's see, shooting angle. So if you click the shooting angle button right here, you click on that, and we'll actually sit there. So you can take and put this on top of your barrel. Hit the capture button, and now it changes all your range calculations. So that's a really handy way. The only problem is the 4DOF calculator is really limited to, for the most part, just Hornady bullets, but that's fine. It's, you know, their app, their rules kind of thing. So, idea is we'll go out, we'll establish 100-yard zeros, we'll calculate everything out from there, we'll create a tri-dope chart, which means that's dope that we're going to try. If you need to borrow somebody's app or something to...
I just downloaded the one.
Okay, cool. Awesome. So you can play with that. It'll be easy to do. So we'll calculate a range table or a tri-dope table, meaning you just go through, calculate it out, and write it down, and then we'll try it. That's why it's called tri-dope. This is the trying part. So, I don't know, do you guys dial or hold, or do you have a preference? I usually
do both.
just
Depending on the range
yeah.
and what I'm trying to hit.
Dial mean changing,
Meaning-
and yeah,
I'd rather hold.
yeah.
I got locked swords, so.
Okay, yeah, that's handy. So that's for today. We're gonna try to get to this today. So what we're gonna do is we're gonna take and engage multiple positions on the ground. So Braxton is gonna, take a target up onto an elevated position. Then we're gonna shoot at it. We're gonna try positional shooting because, like I was talking about, when you're trying to get a position, if you're proned and you're like, oh, the target's up there, it's like prone just doesn't work. So usually you're sitting, you're kneeling, something like that. That's where shooting sticks come into play. Hopefully everybody has a set of something like it. If you didn't get the
You didn't tell me to bring it,
it's
otherwise
I've got a
on you.
tripod.
Yeah, wait,
I've got a tripod in the clamp I can use for saddle and set it up. for
tripod
different
totally works. I've got a couple of different sets and a couple of different things you can try. So it just depends on what you want to do. So what we'll do is we'll start at the bottom of the hill, we'll shoot up, and then we'll just move back. So that way we'll try some different angles. 10 to 15 shots per position. I'm figuring we're going to spend 20 minutes or so at each spot. So we'll be there 2 hours or so. Dry firing, try playing with your position before you shoot. If you shoot and you miss, try changing up your position, find what works. And then, since we're not going to come back in here for more lecture, we'll do depression real quick, and this is going to be the same thing, but shooting down. So what we'll do tomorrow is we'll set up a shooting position on a hill, and then me and Braxton will probably go set out a bunch of targets at various distances from the hill. Let's see, our goals, pretty basic stuff here. This is a learning environment. If you guys are like, I have no idea what you're talking about, dude, ask. That's what I'm here for.
We're going to need some supplies from Braxton, I think, for the zeroing.
Oh, you did the paper targets?
Yeah, because we ran out of stuff
You know what?
yesterday,
I might have some under my seat.
What
I
we
usually
really need
keep
is a
those.
stapler.
I've got one.
We need a,
Awesome.
we need a way to attach. Yeah, I don't know if
I have
that
a
board can
stapler.
even
Problem
hold
solved. You got a
staples.
stapler.
I
got a stapler?
I got a
believe-
hammer
I
cutter.
believe you have my stapler.
We got
You
staples
can't
on
use
targets.
electrical tape to tape the target to wet particle board if you're wondering.
Yeah.
Well, maybe I'll dry it out by now.
I don't think so.
You don't think?
It's pretty rotten.
Pretty
Dude,
dry out.
my tent is still wet. So, but
We can staple them up, maybe.
yeah, I'm pretty sure we
Just
can
stick with
staple.
the stapler.
So learn the skills, practice the skills. Hopefully you guys can take this material home, use it, either in hunting or law enforcement, whatever you're doing, or just for giggles. It's a free country. We get to do that.
What other apps do you recommend? Hornady doesn't work.
Hornady, it's okay when you Hornady is there's a couple of basic free apps out there that are all pretty good. Like I think Hornady has one. I'm trying to remember who else does.
Knight's Armament is another one a lot of people talk about being pretty
Is it?
good.
Yeah.
And then there's a shooter app.
Yeah, there's a couple of different shooter apps out there.
If you want to spend $30, the Applied Ballistics app is good.
Yeah, I was gonna say.
That's just
I
like
just-
a one-time.
I just bought that this morning. Yeah, it's
Yeah,
$30.
if you want to give Brian Litz $30, he absolutely deserves it because that dude puts in the work. But yeah, it is $30. So.
This one?
That's the one.
Or there's also, or at least there was, Straylock Pro.
Can't get
That's
it
not on the App Store anymore.
It's not on the App Store anymore, but you can supposedly get it from straylock.online. If you don't mind violating America's sanctions against Russia and citizens of the country of Russia, you still can do that. I happen to have a pre-banned copy of Straylock, which is probably some of the most absurd words that have ever come out of my mouth. Saying pre-banned software.
I think that SBC Lite is a free app.
Yeah.
I think it's supposed to be pretty good.
Is it?
Yeah.
Usually,
I use Ballistic AE. I had for years, but they've dropped support for it. It's still a good app.
yeah. The biggest issue usually between free apps and paid apps is the ballistics library that drives it. Like these are all mostly using the same ballistics engine. It's just a matter of like, except for Applied Ballistics, I think they have their own, which is part of the why it's so damn expensive. But for everybody else, it's like, okay, how many bullets do you support? You know.
I mean, I can probably, if anybody's having trouble with it, I've got Ballistic AE. I can probably help get a drop table and just screenshot it and send it to somebody's
I just
phone.
Googled the data and hand entered it
Yeah.
because it was easier than finding it in their library.
Yeah.
You can use JBM Ballistics.
Yes.
It's an online. You just go to the web page.
Yeah,
You
I
can
actually
punch in your
use
stuff and get a drop
JBM a lot.
chart.
If you're interested in doing your own charts and doing JBM stuff, I think it's still online, but Dvorosaurus Rex, he's a YouTuber. He had his Sniper 101 class, and I think it's like class like 60 or something in there, 58, 60, somewhere in there. He has a whole thing on developing your own ballistics charts, and that involves taking your data from, like, I'm going to the shooting range, getting chronograph data for like, okay, here's what the temperature is, and then he'll go back and using JBM Ballistics, he's got a template that he uses that's in XLS format. You can download, plug into, you know, Excel or OpenOffice, LibreOffice, whatever, and generate your own charts. That's usually what I've done in the past. And then I changed my ammo, and I'm like, man, I put a lot of work into that for nothing. I think that's it. Any other questions?
Braxton did tell me I was going to feel a lot stupider, and he was right. So
Well, okay, that is not my goal.
no, it's all completely interesting. That's
Yeah.
why I came, but just trying to absorb it all and see. I'll be interested to get out in the field and
Yeah,
apply.
that's really where this kind of comes to play. It's like you can know it academically, but like 90% of shooting is all feel.
Right.
So it's like, oh, you know, and you almost, this becomes second nature. You feel that I have to this. I feel I have to.
Well, a lot of times with hunting, it comes with you don't have a lot of time.
No.
So you're going to have misses. You're going to have things happen, but every experience just gets you that more.
Mm-hmm.
You know, our CWD hunt with me and Braxton, chronic waste disease. I did a once in a lifetime special hunt up in
Nice.
Hell's Canyon and some definitely terrain like the mountains around
Yeah.
here, maybe even a little more extreme. And you know, that was the first time I ever saw somebody dry fire.
Yeah.
You know, he might have done it like 8 times. It's like, oh, okay, go. You just get in the field. Yep, exactly. Just trying to make sure it was the shot that he wanted to take. You know, we had time then, but usually, like you're hunting elk, you literally have, well, not all the time, but in the area I'm in, there's so much foliage and trees and brush. Like you have an opening, he might just walk through and you shoot. There's no, you know, you have to kind of have it pre-planned like before if you're looking at stuff. But the time you have to think is absolutely minimal.
So a lot of the stuff we're talking about here, like, kind of doesn't matter as much when you're getting into these like ultra magnum calibers and shorter ranges.
Right.
Like, I mean, you know, hell, drop and wind are just like, whatever.
Right.
You know, she's like, YOLO.
Yeah, 300 yards.
Yeah. I mean, even you know, if you're shooting this with a 22 at 300 yards, it might matter.
Right.
Like even with a 5.56 or, you know, 30-30. Well, 30-30 it probably might start to matter a little bit more. But,
Sure.
It's like when we had the campfire class from Peter Gold, and his first sentence was, "Anything inside 600 yards is close range." And I was like, "Oh, we're about to have a conversation that's beyond anything that like this guy."
Oh yeah.
For his specific
Yeah.
for what he does, what did he say? Do you remember what he said? He's doing bullet.
Somebody the guy that did the long range campfire thing.
He does like weapons and ammo development for SOCOM.
Yeah.
So like for him, it
he
truly
works with
is.
Todd Hodnett
Yeah.
and what is that? Accuracy First.
Yeah,
All
they
his
do
slides
their.
and stuff like
I
that.
just like I remember that quote, and then I remember him saying that they do their group. When they develop a new round, they test for grouping at a mile.
Yeah, those guys do weird stuff. Like they true at the transonic range.
Yeah.
So like if you're gonna true drop, they're talking about going out to where it's coming in around 1,000
Yeah. So
feet per second or something like that.
I
or
just
it's
remember
like-
him starting. I'll never forget that. Him
That
starting
takes
that
a-
conversation with anything inside
Yeah.
600 yards is close range for the purpose of this conversation.
Yeah, everything I've trued stuff at 500-600 yards, and that's close enough for me for the bullets I use.
Yeah.
But they're shooting well beyond transonic, and they're using applied ballistics and
Yeah.
stuff.
Really, when it comes to a
That's a
lot
lot-
of this stuff,
lot of
you know, depending on what your caliber is, what actually kind of starts to affect things, especially in some of the larger diameters, is your twist rate. Because if you have, like, one of the issues I really have a lot of problems with is my 308. It's a 1 in 10, and if I'm shooting a full house load of 168 grain bowtail hollow point, you know, that comes out at about 2,800 feet per second, and I keep having accuracy issues past 800. And pretty much what I'm starting to figure out is that it's as soon as it drops transonic, the bullet is actually overstabilized. So what happens is it's flying out, it continues flying like this, and as it starts to drop, once that you lose that kind of hypersonic shock, you start to get skin effect, which causes the spin rate to be affected, so it loses stability. And I mean, it's sitting there losing that stability for a while, you know, but then once you get to about 850, 900 yards, if your elevation's low enough, accuracy gone. You know, you start shooting, I start shooting like, you know, 10-foot wide circles. And I'm like, what the hell?
We should probably cut this and the power he's running his generator
Okay,
works and stuff now. So. Is that all?
references, if you guys are interested.
Did you say Braxton will have the slides and we can?
Yeah, I'll put these slides up for you guys, and
Cool.
like right now, these are actually, you know, I did this in Google Slides, but I can either make it public or whatever. I'll probably just send Braxton a copy of it.
Yeah, forward that on. That'd be great. 'Cause I got he said he was going to send more. I just got that one required equipment thing when I asked him
Yeah.
about it.
So, and
I kept
then
texting like, "What you got? What are we going to do?"
the notes have all the formulas in it. So if you're curious, and all the solutions to the various problems. So
Okay, excellent.
if you want to review,
Yeah.
thank you, gentlemen, for attending.
No,
Thank you for the presentation.
Yeah.